In Lesson 15, we'll be working with area and volume. We'll be finding the area of a triangle and a trapezoid, and we'll be finding the volume of a cube and a rectangular solid. As you watch the videotape, if you have any questions or don't understand some of the concepts I'm explaining or the problems, stop the tape and ask a tutor for help. Please take careful notes. The first thing we want to work with today is finding the area of a triangle. In order to find the area of a triangle, or to come up with a formula for an area of a triangle, we're going to first of all go back and see what we remember about a parallelogram. Okay, you see here a parallelogram. Remember, a parallelogram was a quadrilateral in which the opposite sides were the same length and parallel. Now, when we're finding the area of something, we're concerned about the inside of the figure. We want to decide how many little square units there are in the inside of the figure. Now, if we take our parallelogram and draw in a diagonal of it, a diagonal is a segment that connects opposite vertices. You'll notice that the parallelogram has been split into two triangles, and the two triangles are what we call congruent triangles because they're exactly the same size and same shape. You could fit one right on top of the other. So if you put the two triangles together, you would have the whole parallelogram, or the area of the two triangles would equal to the area of the parallelogram. Well, if you remember, the formula for the area of a parallelogram is the base times the height. So, since each one of these triangles is like half of the parallelogram, we can say the area of a triangle then is going to be half the base times the height. And that's the formula we use for the area of a triangle. We say the area of a triangle is 1/2 the base times the height of the triangle. Now let's look at a picture of a triangle and think about this formula and see what we mean by the base and the height of the triangle. You see here a picture of a triangle, and I've written the formula down for its area again. The area is 1/2 the base times the height. Now the base of your triangle can be any side of your triangle. In this case, I'm going to let my base be the bottom, and I have that the base is 10 centimeters. The height, if you remember for a parallelogram, what the height is a segment that goes from a vertex to the opposite side. And it has to come down and make a right angle. So it has to come straight down and form a right angle. So I've dotted in the little segment that comes straight down, and I've told you that it's 6 centimeters. So to find the area of this triangle, we're going to use 10 for our base and 6 for our height. So I'm going to come over here where I have the formula written down and fill in the missing parts. The area then would be 1/2, and this BH means to multiply everything together, so it would be 1/2 times, my base is 10, so I'm going to put down 10, times my height, which is 6, and then I'm going to work that out. I'm going to put 1s under these. Since I've got the 1/2 there, I'm going to treat everything like fractions, and I can reduce 2 into 2 one time, 2 into 10 5 times. So if I multiply straight across, I get 30 over 1, which will reduce to 30. So my area is 30, and I don't want to forget my unit of measurement. I'm working with centimeters. And remember, when we're finding the area, we're splitting the inside of the figure up into little squares. So it's 30 square centimeters written that way, or you could write 30, we could say A equals to 30 square centimeters. So you can write the word square out, or you can put your little centimeter square like that. So the area is 30 square centimeters. Let's look at another triangle. This time, let's move the triangle up so we can see this one a little bit better. This time our triangle is not really turned a different way, but I don't have the bottom side labeled as my base. I have a side over here labeled, and it's 2 1/4 inches. And I wanted to show you that you can use any side of the triangle for the base. So this would be fine to use for the base. But the height always has to be drawn from the vertex down to that, from the opposite vertex down to that base. So if I'm going to use 2 1/4 as my base, then this would have to be my height. My height has to go from this opposite vertex over to that base. So I'm going to use 2 1/4 as my base and 5 1/3 as my height. So when I start to fill in things, I'm going to have, I think I'm going to move down here to work this out. My formula is A equals 1/2 BA, so it's going to be A equals to 1/2 times, my base is 2 1/4, and my height is 5 1/3. Now in multiplying, you need to make everything in proper fractions, so let's do that. We have 1/2 times 4 times 2 is 8, plus 1 would be 9/4, times 3 times 5 is 15, plus 1 would be 16/3. As soon as I make things improper, since I'm multiplying, I'm ready to reduce. So I can reduce with the 2 and the 16. 2 goes into 2 one time. 2 goes into 16 8 times. Then I could reduce again with the 4 and the 8. 4 goes into 4 one time. 4 goes into 8 2 times. And then 3 goes into 3 one time. 3 goes into 9 3 times. So I actually have left 1 over 1 times 3 over 1 times 2 over 1. And when I multiply all that out, I end up with 6 over 1, or 6. And if we go back and look up here in our picture, we were working with inches. So on our answer, we need to put those inches. And because we're doing an area problem, it's got to be square inches. So I write down 6 square inches. Or I could say my 6 and write my square inches this way. Both of those are correct ways to write your square inches. So the area of that triangle would be 6 square inches. I wanted us to look at a triangle that has sort of a different slant to it. This one has a big angle here. We call an angle like this an obtuse angle when you have an angle that's bigger than 90 degrees. And we actually call it an obtuse triangle. But the thing I really want you to be concerned about now is what would happen if you decide to let this bottom side down here be your base, and you wanted to draw your height down to that base. Okay, what you'd have to do, see, your height is always supposed to come from the opposite vertex, which is this. So I'd want to start here and draw a line straight down to my base and form a right angle. Well, the only way I can come straight down is to come out here outside of the triangle. And you have to do that occasionally. In other words, it would not be a part of my picture, but to see where that is, I'm going to dot in, imagining that we might extend this side and dot in a little segment here. That little segment would have to be the height of that triangle. However long this is would be the height. So if somebody were going to tell you to find the area of this triangle, and they gave you this bottom side as the base, and gave you the measurement, they'd also have to give you the height that came from this vertex down to that side. And the only way you can come straight down is to draw it in outside of the figure. So whatever this length is, that would be the number you use for your height, and then this would be your base.